All right, in this lecture, I am going to go over computing internal rate of return, but using Excel rather than the nonsense we were talking about in a few videos before this. Okay, here's the issue. Uh, Usually it's the case that our cash flows are going to be inconsistent every year. So the strategy that we were using in the previous examples, in a previous lecture, don't really work because we were saying that the initial investment of 16,000 divided by the annual cash flow of 3,000, that would give us this present value factor of, I don't know, what is 16,000 divided by 3,000? Um, 16,000 divided by 3,000. It would be 5.33, right? And then we would go through the process of looking at the annuity table, figuring out the number of periods, then going through and finding the present value factor of 5.33, blah, 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 blah. That was an annuity, but unfortunately, more often than not, the cash flows, the future cash flows, are going to be inconsistent. So we can't use this approach. And therefore, to find the internal rate of return can be really, really complicated. However, if we use Excel, it's super easy. And so this slide is basically saying we would just input all the numbers in Excel, okay? And I've done that for us already. So 16,000 initial investment, and then these are the future cash flows. All right. And so now if I want to figure out what is the discount rate that I would need to discount 3,000 in year one, 4,000 in year two, 4,000 in year three, etc., etc., I can just do this formula and it will be equals IRR, excuse me, apostrophe, is that apostrophe parenthesis? Fuck. Then I would highlight everything, close parenthesis, and then I would hit enter. And this is telling me that the discount rate would be 14.47%, right? So if I were to take this, 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 and discount all of these at 14%, then I would come up with 16,000. And I'm going to do that for you guys right now. So this would be equals this, man, divided by 1.14 raised to the first power. Oops. Raised to the first power. And I'm getting a present value of 2,631. Now I'm just going to go change this to the second year. And let's get rid of the decimal points. Okay, so again, it's the cash flows divided by 1 plus the interest rate raised to the number of periods. Okay? So this is year 3. So it's cash flow divided by 1 plus the interest rate raised to the third power. So the 4,000 3 years from now has a present value of 2,700. This is 4 years out. This is 5 years out. This is 6 years out. This is 7 years out. And this is 8 years. And then I can sum all of that up. And obviously it's not going to be quite the same because the discount rate that we we were discounting at was 14.47, I think it was. And I just plugged in 14%. Right? So this is the initial investment. These are the future cash flows. This is the present value of all of the future cash flows. It is all of these. Right? So if I went back in and I turned this into 14, what was it, 49? 14, 4, 14. I'm sure everybody's like, fuck it, I'm logging off. For the one person that's still watching, I appreciate you. Shoot me an email. We'll have lunch. 14.49, right? So slightly lower than the 16,000. Okay. But we can just undo everything and go back to what the book was trying to explain. The book was saying that in order to find the internal rate of return using inconsistent cash flows, we could put it in Excel. We could start with the initial investment. We'll treat that as a negative number. These are all positive numbers. Then we will use the formula IRR, parentheses, and then we will highlight the information we want to calculate. And then we hit enter. And like I said, the discount rate is somewhere in the neighborhood of 14.47.